The Hazel Park Amateur Radio Club DART Weekly Upgrade Update for Monday, September 29th, 2025. And here are three illustrious overseers of the DART: John Teagarden, AAAU, John Little, WATOY, and our dear friend John Pullman, K8ZEC, Silent Key. Okay, so here's our new drawing, and it's not totally new, but the new parts are what I want to talk about today. This is the diagram we will present tomorrow to Team Bearcom, the nationwide company of one of the largest provider of Motorola equipment. They're obviously commercial is really their primary focus, but they do amateur radio, and we'll be meeting with them. They have an office here in Wixom. So we're going to have a Zoom meeting with them tomorrow. And the idea is to show them our plan, and hopefully we can get a couple of cablemen out of it and get the racks mounted and wired up. But the difficult part of this job is not putting in and wiring the equipment, as it can be quite involved. But the real difficulty in all this really is programming. This equipment is generations ago, our Quantar. This is a highly digitized piece of equipment, and the programming is very extensive. So we're hoping to get guidance from them in addition to putting everything together, programming it, and giving us as many features as we would like to have, because this machine does a lot of different things. But I just want to bring your attention down here to the bottom of the picture. This is the usual, the UHF receivers, and then we have from the remote locations, and then we have the four receivers themselves, which are basically my core transceivers that are cut in half, but we use just the receive side, goes to the voter, which then feeds the controller, which we talked about last week, and then the repeater and the duplexer, and out the heliax cable that goes to the antenna. What I want to point out in today's meeting is this section down here, the digital section of it. What we're basically going to be doing, and this is just a very high level approach on what this might look like. Because we have to have network connectivity, we're going to have a number of different VLANs. One of the VLANs would be dedicated to applications like Echolink and IRLP and all the like ham over the internet communication programming. Then the second subnet could be something like this. It could be all for like test equipment. We're going to have a spectrum analyzer there. We'll have the oscilloscopes. We'll be able to look very closely at the signals remotely like we've never been able to done before. And so this is going to be a great step forward. Perhaps the third subnet could be for the repeater control. Currently we have limited remote control capability using DTMF tones. Here, we'll be able to do it over the internet, in addition to being able to do it over the air or over the telephone or however else it's currently being done. Then finally, we have a section here for backhaul and networking services. And the point that I really want to make here, and again, we're just putting placeholders in here as this plan develops, and I'll show you the picture, but this is the back of the repeater. These are RJ45 connectors. There's 1, 2, 3, 4, 5, 6, 7. So if we have just the repeater, we haven't even looked at the back of the controller yet. This is the Quantar, has performed flawlessly over the years, and we're just so pleased with it. And credit goes to John Teagarden, too, AAAU, by the way, who has kept this machine up and running for as long as I've been a member of the club. But you can see that right out of the catalog, just the empty frame. You can see there's no modules in it. This is ours. This is an actual photograph. So here you can see we have modules in those. But you don't see very many RJ45 connectors. Well, in the front here, there's something. We're not sure what we're building here exactly, but we want to make sure that we have plenty of hardware to be able to perform the software functionality. Oh, so here's the repeater, and then here's the Motorola, the Moto Turbo SL8000. Now, this Moto Turbo is their operating system, and the operating system is important. This is a good choice for amateur radio because it is capable of transmitting 100 watts continuous, 100% duty cycle. Then you can do FM or DMR with it. So that now gives the club three options, three platforms. From the UHF site, we'll be able to do fusion and analog FM. From the VHF site, we'll be able to do analog FM and DMR and mixed mode so that all these platforms can come together as one.
It also states right there, its next generation receiver offers high sensitivity and robust blocking, which helps pull in weak mobiles and congested sites. That's perfect for the DART.
But the receiver is not only very sensitive, the filters and the front end is spectacular. And it's built for an environment of high intensity RF field. And it has all the digital aspects of it too, Ethernet, USB, DB25. Also, it'll deal with the battery. Let's say we're in a location where there's no generator backup, so it's a good piece of equipment. And again, this is what the back looks like. Okay, you can see it's very simple. And look at very small. You know, the other thing about that tall rack is the size of this equipment will easily fit into a half a rack. So we have plenty of room for expansion.
Hey, I got a question about the new repeater. With the operating system that's in it, can we install Echolink or All-Star or like whatever digital mode we want to do? Can that be in the repeater or does it need to be a separate box? I mean, for like IRLP, do we have to have a Raspberry Pi up there or can we do it in the repeater? Was there a card or a module that we could put into this rather than having another outboard piece of equipment?
So, and we'll talk about the role of the controller, which we talked about last week.
Joe, I got a couple questions. On the back of that thing, okay, it looks like you got two in the middle there at the bottom. Looks like you got, those almost look like Ethernet ports. Are they?
Yeah, so in the middle is IP control. And if I remember right, when I read the manual, I believe the 5 on the left-hand side above the power supply, I think that's the breakout to the audio interfaces so that's where your remote receives go in. If you use a Motorola remote receive that basically can just use an Ethernet cord between the two, and the TX, the RX, the PTT, all that stuff is all included in that 8-pin copper. So they're just using an RJ45 connector, but it's not actually Ethernet. The two in the middle at the bottom are Ethernet.
And there's a USB connector there too.
Yeah.
There's one on the front. Now I know on my, I've got an MTR 2000 for my repeater, and it's got an RJ45 for programming. It's got a mic and an RJ12, I think, for microphone, and it's got another one for an RJ9 for a speaker. You want to have a separate speaker so you can hear what's coming in when you're working on it. Maybe to that left fan, maybe there's a speaker.
Well, there's a fan here and a fan here. So if it was a speaker, it would either be here or sometimes they put them on the back.
Yeah, there's a volume up and down on the front panel there on the left. So that's an indication that there could be a speaker.
It has a lot of potential and a lot of functionality that over the years we will be able to learn about and understand how to bring it all together. So this is our current controller. Now, again, very limited and very cookie cutter installations. You can use the controller that's built into the SL8000. However, being amateur radio operators as we are, curious folks, and the specialized functionality that we need, such as speech synthesizer, who comes on every half hour and identifies us, our CW identifier comes out of the controller, compact microprocessor-based repeater built specifically for amateur use. This is about 30 years old, this piece of equipment. Fully remote programmable via DTMF commands over the telephone or receiver ports, and data stored in non-volatile memory. This is how it's hooked up. These are our remote receivers. When we had 4 of them in operation, goes to the voter, and the other additive to the voter's receiver on the main repeater. The output of voter feeds the controller, which adds the tones and IDs, and then sends the audio to the repeater. Okay, so this is the replacement. I'm a little bit confused here. And the reason I'm a little bit confused is what we're looking for is the RC210 as we see at the top here, that picture in its own.
That's what I have on my repeater.
Yeah. Oh, did you have it in this form? Or I could only find the circuit board. I couldn't find it for sale actually in a box. Do you have it in the box?
Yeah, so my panel's white. I'm very familiar with this controller. It's a great controller. The only thing I don't like about it is that it doesn't have a web interface. And I think he's maybe planning to put one in down the road.
It doesn't have a web interface?
No, you can't just plug in Ethernet cable into it and access it from the web, which would be great.
You know, last week we had this presentation on controllers specifically, which was so interesting putting it together. Repeater control functionality.
Can I ask a question, Joe?
Yes, please go ahead. Mike, go ahead.
You mentioned no Ethernet, so no connection. Does that mean if something happens and for some reason we want to shut down or restart the repeater or do anything, we have to be on location? Is that what that means?
So I am remoted. This screen you're going to see coming up.
Okay, we see it.
I'm remoted into this is actually at the site. So I'm remoting into the site, and here's this is the ARCOM. I open this up. This is the latest file. This is the control, so you can change. Here's your port controls for your timeouts, your courtesy tones. You set the frequency and the spacing. You have all kinds of macros. It's kind of cool. And over here on the right, they show you what each of those numbers mean. Like this says 01. If I look over here, 0.
So when you said that you couldn't access it remotely, maybe
I said if you don't have, you can't access it if you don't have a separate PC.
you're remoting into the PC over the internet, then the PC is talking to the box. Got it. Yeah.
Right. So I can make any changes I want here. I can even, I can do all kinds of things. And then all I got to do is hit this button, download. And it'll ask you, do you download everything or just changes? And when you do changes, it's really fast. It's just like, boom, it's done. If you just change one or two things. This is the new repeater setup. This is the Motorola. You see I have to have an external speaker, and that's my duplexer down there. That's a Phelps Dodge 6-cavity. This is the inside of the SCOM. Now, I did a lot of modification of mine. There's cables. These wires are not normal. That doesn't come with it.
Nice work, though.
I've got two PL boards and a bunch of stuff and a bunch of things going on here. I have two PLs. If you go in on the other PL, it acts like a different machine, and you can control it not to go out through the All-Star link, and basically it's using two ports. And the back of the MTR 2000, and this is an interface board I bought. It plugs right in the back, and you access to...
What are you connecting into it?
That's where the controller connects. See, here's the controller up here. This cable goes down and comes into here. The way Motorola does things, I had to pick one line from the DB25 because I needed a line that allowed the PL to come through. And the pure raw data discriminator out of the other connector, that you can't get that. You can only get processed audio. That's filtered. So I had to grab a line there.
Is that third party or is that Motorola?
It's third party. It fits right in, and the guy makes a beautiful board. It's the same guys who do SCOM.
Oh.
And then I've gotten preamp on the back. They just stuck on a separate preamp.
And those are your duplexers down there. Is that what's on the bottom on the floor? Is this 450? Yeah, that's why.
The control cables, this white cable, you can see they terminate in RCA jacks. And I put RCA jacks on the controller on the RC210. Makes it real easy rather than unscrewing and everything. They just unplug. And that's why all these wires are here, because they connect to the same pins on the ports so they're all right there also. You can do it either way, from either right in there like this one is. For the main one, I have it all like this. Audio in, audio out, carrier, push to talk, and PL in and out. There's the ARCOM controller, and this is the All-Star node is in a separate box, which is connected to a port. And then up on top here is a PC with a monitor up above it. And that is connected to the internet. And that has a cable going from the serial port of that to the programming port of the ARCOM. So I can remote in.
We actually have the same setup currently for the actual repeater, the Quantar. We have a PC with remote access, and then there's a USB to serial going into the Quantar so that we could adjust power, adjust squelch, that sort of thing remotely.
a dial-in modem. You're totally on internet, right? It's fine. It'll work. It'll do the job. And when are they coming out with the AI version of this? Anyway, all right. Wow, that's great. Phil, thanks. Yeah, yeah. There. Now so you should see this. So here, the ARCOM RC210, recommended by Phil. And it looks like exactly what we wanted to do. So, okay, very nice. Years ago, when I first joined the club, when was this done? I think 2017 or something like that. But anyway, we did a frequency test. Back in those days, the Fusion, the Yaesu Fusion repeater, which is out at the water tower now, but it was at the VHF site there. So we ran, John AAU and myself ran these tests where we put in various frequencies just to see how flat the audio amplifiers were and things like that. But very interesting. So if you look here, you can see at 400 hertz, right? 400 hertz. And remember, the input, coming out of the test generator was all the same. It was plus or minus like a quarter of a dB. But this is after it went through the system, all the wiring that's in our current rack. So here at 400 hertz, you can see it's gangbusters. We're clipping at the top. You double that, go to 800 hertz. You can see the clipping has come down a little bit, so has the amplitude. And finally, when we're at about 1.2 kilohertz, you can see, all right, now we're starting to get a decent looking sine wave. So this is about the highest level that you can put into it. Now, as you continue, so here we're 1200 hertz. Now we go to 1.6 kilohertz and then 2 kilohertz and so on. But you can see as we're going up in frequency, what's happening? The amplitude is taking a nosedive, and it looks something like this. So what I was just showing you there is this curve here. This is the output of the SCOM, the input to the Fusion. So we know it's not the transmitter itself, it's the circuitry within the rack. But you can see as we go up in frequency, how it's not very linear, and it should be straight across. It shouldn't be taking a dip like that. This is a region of highest intelligibility. In other words, of our voices, the male voice, right, from 500 to 2000 kilohertz is where most of the information takes place there. They call it the high intelligent information. Anyway, the point is, I was telling this to somebody, and they said, well, it's de-emphasis, it's pre-emphasis, FM, you know. Well, no, because look, here's the de-emphasis curve, okay? It looks like that. So it has nothing to do with that. So when we build our rack, we want this to be straight across like this, straight across, and then above, I'd say 3000, quite frankly, but okay. We should have a complete linearity in the audio section there. This was taken a number of years ago, 2017. It's not as nice. There's a lot more stuff there now than there was back then. This is what the inside of the rack looks like now. And then there's other racks that Hugh drove up with Mike, and they brought him down from his place up north. This was what was at one point currently in our rack, and it's about 85–90% still true today. So we'll talk about that. And here's a closer look at some of the equipment we have. And one of the things we really want to stress is you can see the wiring is much to be desired. So we want to get that done, get cable harnesses in there, cables cut to length, and that will last 40 years is what we're hoping, through to the next generation. So here's the 7K, the SCOM 7K controller, as you can see, and then that's the voter there. We have a voter, and the voter is supposed to vote and make all the right decisions. Here is, the 4 receivers, as we mentioned previously. Now, there's a maximum of 8 remote receivers possible with this particular voter, but there's so many new choices these days with All-Star and some of the others. So we'll take a look at that, but this is what's called signal-to-noise voting. So it basically measures the amount of noise, quantifies it, and then gives it it goes to a comparator, which will compare 3 or 4 different signals, and depending on which signal has the least amount of noise, that's the selection that'll be made. And then that audio, as you can see, is passed through to the controller. We do have the CTCSS filter in it because they're depleted already, and we used them. That's really a function of the receivers to trip the squelch in the receiver. So we don't want to retransmit. That's not necessary. So we just filter that out. This is how the voter analyzes the noise. Obviously, it should pick this on the right. This is a pure sine wave. You can see it's much cleaner. On the left, there's all that noise in there. And if you look at it from a modulated voice standpoint, this is a sine wave. But if you just put modulated voice there, you can actually see the noise in there. This is audio with full quieting, so you can see the difference. So again, this is what the voter has to deal with in terms of picking the best sounding signal. The controller is audio, off-air audio, which is from the received audio. And then the other function of the controller, as we talked about last week, is on this branch bringing in our receiver audio number 2, our input number 2, and the transmit audio number 2. And that goes to and from all the internet applications, IRLP and Echolink and all that. So that's what that is there. Here's the inside of the voter. If you look at these integrated circuits, that's how old this is, but it's reliable. It has been not off the air since it's been turned on. So functionality and the ability to really discriminate against the signals we want to hear and the signals we don't. So here we're looking at a footprint. This is the coverage area, calculated theoretical coverage area of the DART. As you can see here in this square, this is Oakland County. In this square, that is Macomb County. In the upper left-hand corner, there's no coverage. And that has been confirmed by more than one individual numerous times that we have no coverage up in the upper northwest corner of Oakland County. And we could probably use a little refresh here in the northern part of Macomb County. So how would we do this? Well, we already bought the antenna, so any ideas about getting a different antenna, that's not going to do it. So if you draw a map here, Oakland County on the left, you can see in red, Macomb County on the right. Okay, and then we complete the rectangle right here. And we draw this X. So this is the exact geographical center if you wanted to be able to cover Oakland County, Macomb County 100%, okay? So let's zoom in on that a little bit. Oh, so this is what it actually looks like. It's in the middle of this golf course, but where is this golf course? Well, if you look up here, this is Oakland University. As a matter of fact, this building right here is the engineering building. Just the ground level is 242 feet higher than it currently is in Oak Park. So that will add roughly 22 miles to the radio horizon, according to our calculations done. Thank you, ChatGPT. Do they have an amateur radio club at Oakland University? Unfortunately, they do not. The closest thing they have to it is WXOU 88.3, the student radio station. But they're open to starting a club. If we contact the Office for Student Involvement, they'll be more than happy to sort that out. Here you can see the geography. This doesn't quite go up that high. This was from years ago. This is our north site. And so here you can see this is the DART is right here. These were the remote receivers that we had at one point. Oakland is actually up even further. It's up off the map here. But you can see the gradual increase in elevation. And by moving the repeater west, not only do we gain in height, but the added elevation will increase our coverage area sufficiently, and we'll be able to cover all of Oakland County and Macomb County.
What are we still waiting for antenna farm as far as deliveries?
I know some pieces have arrived. If Len is aware and what has come in so far.
Well, you brought over the cabinets, and then what came before that was the duplexer. That's here in the box. And then the grounding bar, some fittings that go with it. Those are the things that have arrived so far.
So where's the antenna? They could have drop ship it. If they don't have it in stock, they could have drop shipped it from the company.
Well, that's what they did with the duplexer. It was drop shipped. I had no warning that it was coming. It just showed up on the porch.
When will the decision be on purchasing the equipment?
We're not exactly sure how this is all going to unfold, and not really sure exactly what information they're going to need, but they're certainly going to need more information than what our initial meeting has.
Actually provide the repeater, Motorola dealer.
Well, let's take a look and let's see what we have. if they could be a turnkey operation and give us a price, and they do the ordering, they do the receiving, they do it all.
Oh, yeah,
That would
write
be an
them a
ideal
check.
situation, and get the racks built and on the way.
I just want to point out, I am working part-time for a Kenwood dealer.
You know, if they can't do it, well, we have an option with Phil's Choice.
That's very true. Thanks, Mike.
Why don't you have them quoted as well? You want to get a couple different quotes and compare apples to apples. You can't just throw out for one supplier and hope for the best, right?
Yeah, it's been a little more scientific than that, but that's a great point.
I mean, we sell to a lot of public police, fire, and stuff like that.
Definitely, we could use that as an alternate source. You're right.
Yeah, and I can testify now for receiving the dart, that outer ring at 18.6 miles, when I was working in Grand Blanc, just south of Grand Blanc, that is pitch point accurate location for the outer reaches of hearing the dart. It was north of Holly, on Holly Road, just south of Grand Blanc. And there's a lot of good hills up there, and I was able to hear the dart and work the Lake Angeles received site, the north site, when it was at the observatory. And it was perfect. That location was the perfect site for a remote receiver. So when I hear you talking about, directional antennas and this and that, well, if we're at the same location here, it doesn't really matter at that point. We're probably right to the edge of Genesee County almost. You can't get that much more unless you add some more power to the transmitter, right? To get all of Oakland County and Macomb. The problem that we're having is receiving in those areas, getting back into the dart from that location. And remember, you start pushing to those northern edges and northern, like Rochester Hills, Oakland University, you're starting to get out in the rural areas, and there's not that much activity out there as compared to, here around the city and Hazel Park, quote unquote, area, the radio club. It's going to be basically, you're going to have to put remote receive sites now down along the 696 corridor to be able to work all the mobiles to be able to transmit it back into Rochester Hills. So, I think you want to keep the location in the general, metropolitan area as opposed to on the rural edges of the counties. Now,
we already have the airport and east side for remote receive.
Well, right.
Just a proposal. He isn't moving nothing.
Right.
I'm
So
hopeful.
anyhow, there is another gentleman out here that has offered his future repeater on UHF to be a perhaps Northern Macomb St. Clair link back into the dart. So we can keep that. Yes, we can keep that further down the road, maybe through All-Star or some other mode. But he has offered, when he gets his repeater up and running, he might like to become part of, the dart system. So
Any other questions? All righty then. So we'll see everybody here. Phil, thanks for joining us. We hope to see you again. And John and Len and Al, Les, Mike, and of course Dave. All right, good night, everybody. Take care.
73, everybody. Be well.